All right, so once you have all the correct materials and weights assigned, next thing we want to do is get the robot positioned. So in other words, we have your overall robot assembly. We're eventually going to be putting this on a competition field, but we want to get everything positioned. So you have a front, top, and a right plane that are part of the overall general assembly. And of course, the intersection of all these will be where the origin is. So when we use the mass tool to determine the weight of the robot and the location of the center of mass, we want to know what those coordinates are with regard to. So what I'd like you to do then, I'm going to go down to all the assemblies, so you can see that first of all, on the top plane, you can see that I have this set so that the robot is this bottom face right here, right? This face, let me just, so this bottom face right here is 1.5 inches above the top plane. Okay, so in other words, the top plane of the overall assembly, which is right here. Whoops, that's of the arm motor structure. There's a top plane right there. Okay, so that there's a constraint between the bottom face here and that top plane is 1.5 inches. So if we look at this from this front view here, you can see that the traction wheel is pretty close to actually being 4 inches in diameter. So that's right on that top plane. The Omni wheel is actually, the diameter is a little bit bigger than 4 inches, but just to keep things simple, again, I just want to take the bottom face of that channel and put in a distance constraint so that it's 1.5 inches, because it's a 1/2 inch from the bottom of the channel to the center where the axles are, and with a 4-inch diameter wheel, it's going to be 2 inches above the plane. And then another constraint I have in here is with the right side plane, and that is constrained with this face right here. So in other words, the face of that channel is going to be constrained to the right side plane. Right, that's the right one. And then the front plane right here, I have that one constrained so it passes right through the center. I constrained it to this point. You can pick either point here, right? Actually, I have my filter on right now. So you can see that point right there, if you constrain that onto the front plane, then this longitudinal plane that goes right down the center of the robot, so that is going to be our 0, 0, 0, right? Is going to be on the floor, right in the middle of the robot and lined up with this front bumper. So for instance, if I were to go in and pick a point, let me pick a point on this front edge right here, the front bumper. So if I pick that point and look at the bottom, you can see that, yeah, my X is 0 because in the X direction, that's where I am, right? If I go down, suppose I go down and look at this channel right here, right, and maybe pick this point right there, now I can look down and say Y is 1.5 inches, all right? So that's because, again, if we look at our coordinate system here, right, the X would be 0 on the front bumper, and the Y underneath that channel would be 1.5 inches, and so on. So so this allows us to know when we see coordinates what they're with respect to. So I'll have to pick up with the next video.